Hello, in this video today we shall learn factor theorem. Let's proceed. Now what is a factor theorem? If fx is a polynomial and alpha is a real number, then x minus alpha is a factor of fx if and only if f of alpha is equals to 0. What does this mean? Now let's recall the remainder theorem. Suppose for example a polynomial fx is given which is divided by gx is equals to say x plus alpha. Then we know that we can obtain the remainder rx by simply putting the value of minus alpha in fx. Now, what does the factor theorem say? If, while after putting the value of alpha in fx, if the value comes to equals to 0, that means that there is no remainder left, then x plus alpha is one of the factors of the polynomial fx. Remember, we follow the same remainder theorem. If there is plus alpha, then we put minus alpha, and if there is minus alpha, then we put plus alpha to get the remainder. This is the factor theorem. Now let us try and understand this by doing some problem. Now let's look at this problem. It says, by factor theorem, show that x plus 3 is a factor of 2x squared plus 5x minus 3. In order to solve this one, first we shall find the remainder. So let's write fx is equals to 2x squared plus 5x minus 3 and gx is equals to x plus 3. We need to find the remainder rx. Now to find the remainder rx, in fx we'll replace all the values of x by minus 3. When we do that, then we get 2 into minus 3 square plus 5 into minus 3 minus of 3 implies 2 into, since negative square is positive, we don't write the positive sign, 3 square is 9, plus into minus is minus, 5 3s are 15 minus 3. 2 into 9 is 18, minus 15 minus 3 is also 18. 18 and 18 cancels, so we get the remainder 0. Now, since the remainder is 0 when 2x squared plus 5x minus 3 is divided by x plus 3, therefore x plus 3 is one of the factors of 2x squared plus 5x minus 3. Now let's look at another one. This is slightly different. Here fx is given 2x to the power 4 minus 6x cubed plus 3x squared plus 3x minus 2, and we have to prove that it is exactly divisible by x squared minus 3x plus 2. So how do we do this one? Let's look at it. First, let's write fx is equals to 2x to the power 4 minus 6x cubed plus 3x squared plus 3x minus 2. Then our gx is x squared minus 3x plus 2. Now we haven't learned how to find the remainder when the polynomial is given in this form. So what we do is we first factorize gx. So we can factorize gx by breaking the middle term. We can write this one as x square minus 2x minus x plus 2. I wrote it this way because I know minus 2x minus x will give me minus 3x. At the same time, 2 into 1 will also give me the product of the coefficient of x square and the constant term. Now we can write x common from here. So it becomes x minus 2 minus 1 common here, x minus 2, again x minus 2 is common, so x minus 1. So we have factorized gx. What does this mean? This means that both x minus 2 and x minus 1 are the factors of x square minus 3x plus 2. But we need to prove that fx is completely divisible by gx. In order to prove that, it is sufficient that if you prove that x minus 2 and x minus 1 both are the factors of this fx, then we can prove that this is completely divisible by gx. So we first find out whether x minus 2 is a factor of fx or not. For that we need to find out the rx. What is rx in this case? F of 2. So what is f of 2? 2 into 2 to the power 4 minus 6 into 2 to the power 3 plus 3 into 2 square plus 3 into 2 minus 2. Now let us simplify this one. 2 is multiplied to 2 to the power 4 will give me 32. Then 2 cube into 6 will give me 48. Then 2 square into 3 will give me 12. Then 3 into 2 will give me 6 minus 2. So let us add all the positive signs first. 6 plus 12 is 18. 18 plus 32 is 50. Then add the negative signs. When we add the negative signs, minus 48 minus 20 minus 2 will give me again 50. That's equals to 0. This shows that x minus 2 is one of the factors of fx. Now let's find another remainder r dash x when fx is replaced by 1. So we find f of 1. So when we do that, what do we get? 2 into 1 to the power 4 minus 6 into 1 to the power 3 plus 3 into 1 square plus 3 into 1 minus 2. So when we simplify this one, 1 to the power 4 into 2 will give me 2 minus 1 to the power 3 into 6 will give me 6 plus 1 square into 3 will give me 3. 3 into 1 will also give me 3 minus 2. So if we add the positive signs, 3 plus 3 is 6, 6 plus 2 is 8. Then we add the negative signs, minus 6 and minus 2 together will give me 8. And the end result again is 0. That means x minus 1 is also divisible. X minus 1 is also the factors of fx. So we have proved that both x minus 2 and x minus 1 are factors of fx. Hence fx is exactly divisible by